But if you're absent, I'm going to start doing this every time I teach notes. So Ms. Minnow said she'd post it on the web page. So if you're absent, look for the video instruction. So today, the notes are solving square root equations part 1. So Ms. Minnow put some little graphs on here for us. She thought it might be a nice idea if you could kind of visualize graphically what these square root equations would look like. Okay, I've never done this before, but it's kind of interesting. So on the right side, if we just have equals 2, that would be a horizontal line at 2. So we would have something that looks like that. Okay, if I'm graphing the left-hand side, I can see the parameter changes in there, right? Underneath the square root sign, +1, that means I go left 1. And then the +8 means I go up 8. So it would look like something here at -1/8. It doesn't have a negative sign in the front or in front of the x, which means it opens like the parent. So it's going to go up and to the right. So how many points of intersection do you think this is going to have? 0. So this one's going to be a no solution. So sometimes you can kind of visualize what it looks like graphically, and then that'll help you to know that your algebra is right. So if you're solving it algebraically, you want to isolate the square root expression. So the way we do that, we solve by following PEMDAS backwards. So the first thing we're looking for is any addition or subtraction. You see anything added or subtracted that's not underneath the square root symbol? The +8, right? So we want to subtract it from both sides. And so this is where I want you to realize that it is no solution, because there's a rule that the square root of something can never be a negative number, and that's over here on your notes. So the square root of anything cannot equal a negative number. So when you get a square root symbol that's completely isolated and by itself, and it equals a negative number, you know it's no solution. Okay, so that can happen. So the next one she gives us, if we think of it graphically, it would look like a horizontal line at y equals 15. And then if I'm going to graph the square root portion that's on the left, it looks like the +4 is going to be left 4 in a negative direction and up 1. And from there, it has that 2 in the front. So it's positive. It's going to open up, and it's going to be a little bit steep. Does it have a solution? Yeah, it's going to have a solution. They're going to cross. So now we're going to solve it algebraically. So if I'm following PEMDAS backwards, what would I do first to isolate the square root? Good, subtract 1. So I took care of the addition or subtraction. Now I need to look for multiplication or division. What would I do next? Good, divide by 2. It cancels out. And so I'm left with the square root of 3x plus 4 equals 7. So now that I have the square root isolated, I want to get rid of it. So the way I get rid of it is I square both sides. Okay, so first we want to isolate it, then we square both sides to get rid of it. So square, square. Square cancels square root, and then the 7, I have to square it. So now I'm done with my square root symbol, and I'm just going to solve for x. So the first thing I'm going to do is subtract 4, and then I'm going to divide by 3, and x equals 15. Now, normally when I'm solving these, what I would do is I would take the solution and plug it back into the original equation to make sure that it makes a true statement. If it doesn't make a true statement, then it's extraneous, so it's not really a solution. But today we're just going to focus on solving, okay? None of them are extraneous today. So tomorrow we'll start whenever we get an answer, we'll plug it back in and make sure that it works, but we're not going to do that today. Okay, so the last one. If I look at it graphically, I would graph a line at y equals -6. And then on this side, I've got a right 6, because insiders lie. I've got an up 14, so it would go right 6, up 14, maybe up here. And then I have a negative sign in the front. What does that negative sign tell me? Yeah, it's going to reflect over the x-axis, so it's going to open down. So because that line goes on forever and ever, they're going to have a solution. There's going to be a solution. So now let's look at solving it. What would y'all do first? We're looking for that addition and subtraction. What is added or subtracted? Good. So a lot of people look at this and say add 14, because that leading term doesn't have a sign, but it's really a positive 14. Okay, so be careful with that. So we want to subtract 14. We bring down the negative sign. Square root of 7x minus 6 is equal to -20. Okay, so it kind of looks like no solution right there. But I have a negative sign in the front. So I have to get rid of that because the square root symbol isn't isolated yet because of that negative sign. So how do you get rid of a negative? Divide by -1. Good. It's kind of like an implied -1. We divide by -1. It cancels out. And so now on this side I have 20. So it's good. It's positive. So I can keep working it. I've got the square root symbol. It's all by itself. So how do you get rid of it? Square both sides. Good. Squared cancels square root. You can square 20. Next, what would you do? Add 6. Next, what would you do? Divide by 7. So what 7 goes into 45 times with a remainder of 56, 58. Okay, so tomorrow we'll start whenever we get an answer, we'll plug it back in and check it and make sure it's not extraneous, but it doesn't ask you to do that on the homework today, and it's not in your notes, so we're going to do that part tomorrow. There's one particular question on the homework that kind of bugged people earlier. It's number 7. So if you want, we could look at number 7 on ice skate. Okay, so we didn't have one like this in our notes. It's a little bit funny looking. Okay, what do you think you would do? What would you want to do? Simplify them first. Well, the square root symbols are really by themselves. They're separated by subtraction. The way I would do it is I would add this square root and move it to the other side so that they're both isolated. So now I have the square root of 21 is equal to the square root of 5x minus 4. Okay, so I have a square root on either side. There's nothing else there. So I want to get rid of my square root symbols. What would I do? Square both sides. So square cancels square root. And so from there, you could solve it, right? It just looked a little bit weird because it had two square root symbols. So I kind of wanted to look at that. So I think you guys could finish solving that one. So I just took the negative square root, added it, moved it to the other side. Once I had a square root isolated with a square root, I can square both sides, cancel out the square root symbols, and just solve for x. Okay, do you guys have questions over that?